Let's talk about external sorting. Ano nga ba yung tinatawag natin na external sorting? When we say external sorts, a class of sorting algorithm that can handle massive amount of data. Thus, this algorithm are applicable in the external memory model of computation. And external sorts generally fall into two types. We have what we call the distribution sorting, which resembles the quicksort, and then the external merge sort, which resembles the merge sort. The latter, in which i-discuss natin later on, uses a hybrid sort merge strategy. Kagaya ng typical merge sort, meron siyang sorting pace at meron siyang merge pace. But in the sorting pace, the chunks of data small enough to fit in the main memory are read, sorted, and written out to a temporary file. And then merge pace, the sorted subfiles are combined into a single larger file. Question now is, why do we need to do external sorting? As mentioned before, we cannot fit the entire file in the memory. External sorting is required when the data being sorted do not fit in the main memory of a computing device. Usually, tatawag nating RAM or the random access memory. And instead, they must reside in the slower external memory, usually a hard disk drive. Therefore, we break up the file into a fragments, small enough to store in the RAM or the memory. We sort them and then we merge them back together. So to keep the sort as time efficient as possible, we just need to minimize the read and write operation on a hard disk. The external merge sort algorithm. It is a keyway merge algorithm that sort chunks. Chunks ang tawag natin doon sa mga fragments na nakuha natin upon dividing our data that each fit in the RAM, then merge the sorted chunks together. When we say keyway merge algorithm, we're talking about, also known as keyway merge sorting a data stream using repeated merges. So it distributes the input into a K stream by repeatedly reading a block of input that fits in the memory called a RAN, sorting it, then writing it to the next stream, merging the runs from the K stream into the output stream, and repeatedly distribute the runs into the output stream to the K streams and merging them until there is single sorted output. So that is what we call the keyway. Kaya siya keyway kasi yung K dyan, that is the number of merging na gagawin natin. Mamaya papakita natin through a example. So, suppose we have 500 megabytes of data and we only have 100 megabytes of RAM. So, hindi natin pwedeng i-process lahat to dito sa ating memory. To do that, we read the first 100 MB of data in the main memory and then sort them. Ibig sabihin, from 500 MB, i-divide natin yan into chunks. Each consists of 100 MB para magkasya doon sa ating memory. We write the sorted data to the disk. After natin siyang i-read sa memory and sorting them, ibabalik natin siya doon sa ating disk. And then we just repeat steps 1 and 2 until all the data is sorted in 100 MB chunks. And then the next step is to merge them into single output file. So paano 'yon? Okay, ito na yung ating disk in which we have the sorted data. We read the first 18 MB of each sorted chunk into input buffers in the main memory and allocate the remaining 10 MB for an output buffer. Ano pong ibig sabihin nun? Ang sorted data natin, i-divide pa natin yan into, for example, 5. Each has 18 MB. The question is, bakit 18 MB? Remember na ang memory natin ay meron tayong 100 MB. And kailangan natin mag-allocate ng memory for the output. So, we only need 90 MB for the input. Output is 10 MB. 90 MB divide by 5 kasi 5 ang chunks natin. So, we need 18 MB for each. So, we perform a 5-way merge and store the result in the output buffer. And then, ulit-ulitin lang natin yun until matapos natin yung pag-merge dito sa mga chunks na meron tayo. Just like this one. Okay? So whenever the output buffer fills, write it to the final sorted file and then empty it. And then whenever Any of the 5 input buffer naman ay mag-empty, fill it with the next 18 MB ng data until we come up with one single file of data, which is yung 500 MB na, which is sorted na siya upon storing dun sa ating, pabalik dun sa ating disk. Pakita natin through an example, creating the temporary file or yung tatawag natin na run. Suppose we have the following values. Ang una natin gagawin dyan is to divide each. Okay, we have the temp1, temp2, temp3, temp4, and temp5. So we have 5 temporary allocated para sa kanila. Next, we sort the run. So each temp, kailangan mo siyang isort like this one. For temp1, for temp2, temp3, 4, and 5. After sorting them, we now merge the run until we come up with one single file. The question now is, how does merging work? Paano ba gumagana yung merging? Remember kasi, once na nagbe-merge tayo in a merge sort, sinusort niya na yung data. So, paano niya sinusort yung data upon merging? To do that, let's give an example. Kunin natin si temp1 and temp2 doon sa example natin kanina, in which meron silang tig-5 elements. So we have dito sa baba, this is our output buffer. Dito natin ilalagay yung i-merge natin na dalawang temporary. First, we need 3 pointers. Pointer 1, pointer 2, and pointer 3. Ang mga pointer natin is initially nakaposition doon sa first value ng array natin. Okay? Gagamitin kasi natin yung pointer, dyan tayo magko-compare ng values and then dyan din tayo maglalagay ng ating value. Start tayo by comparing the first pointer and the second pointer, pointer 1 and pointer 2. We have 3 and 7. So since ascending order ang sorting natin, we compare them who is the lowest value or which is the lowest value. So 3 is lower than 7, therefore 3 will be copied to our output buffer. And then next, 11 and 7. So, magmumove tayo ng pointer natin sa temp1 kasi nakopy na natin yung ating first value which is 3. And then before comparing, magmumove din tayo ng ating pointer dito sa ating output buffer kasi dito naman tayo maglalagay ng value. So, compare now 7 and 11. 7 is lower, so we copy, move the pointer, move the other pointer, and then compare the next value, 11 and 12. Copy 11, move the pointer, move the third pointer, and proceed with 18 and 12. So, continue ko lang yung process. 18 and 12. 12 is lower, so we copy 12. We move the pointer from 12 to the next value. And then, the output buffer, yung pointer natin, move ulit natin. Continue tayo na comparing 18 and 17. 17 is lower, so copy. Move the pointer and another pointer, then move to the next. 18 and 30. 18 is lower, so copy 18. Move the pointer from temp1. And then move the pointer in the output buffer. So we have 25 and 30. Compare natin. Copy 25 since lower siya. Move the pointer on the temp1 and then in the output buffer. Proceed sa next, 36 and 30. 30 is lower, copy 30, move the pointer from temp2 and the output buffer, and then compare the last two remaining values, which is 34 and 36. 34 is lower, so copy 34. So nasa last value na tayo ni temp2, kaya hindi na tayo makakapag-move ng pointer. Kay output buffer na lang tayo mag-move. And since 36 ang nahuhuli, we just copy 36 into the last output buffer. So, ganun yung process upon merging sa ating merging algorithm or merge sort. So, kung paano gumagana using 2 array or 2 temporary, upon merging 3, 4, or 5, ganun din yung susundin natin na process. Now, the cost of merging. The problem with the merging or external merge sort is that if the source file has n records and the memory can store m records only, we need n all over m temporary files, kagaya ng ginawa natin kanina. 500 MB yung ating N, which is yung record natin, and then ang memory natin, kaya niya lang mag-store ng 100 MB. So, we divide them, and then meron tayong nangyaring 5 temporary files. We need to read and write each record twice. So, once during the sorting and once during the merging. So, because this is the most time-consuming task, the cost is twice the N. So, halos twice ng N, which is yung ating data, yung process natin. And merging uses many tapes or temporary files. Ang tapes kasi, kung familiar kayo, before the hard drive, ito yung madalas na ginagamit. To solve that problem or disadvantage ng external merge sort, may tinatawag tayo ngayon na polypace merging. When we say polypace merging, an algorithm which decreases the number of runs at every iteration of the main loop by merging runs into larger runs. Sabihin, nagmi-minimize tayo ng mga temporary files na ginagamit natin. So, let's assume we have 3 tapes, 3 tape lang or 3 temporary file lang ang meron tayo. And then we merge in the following sequence. First, we sort and distribute the records into T1 and T2. Merge T1 and T2 onto T3, leaving some on T2. Merge T2 and T3 on T1, leaving some of T3. Merge T3 and T1 onto T2, leaving some of T1. And merge T1 and T2 onto T3, leaving some of T2, and so on. So, example natin, we have 3 tapes. And then, may value ang tape natin na 3, 11, and 18. Ang tape 2, we have 5 elements. And then, ang tape 3 natin is empty. Ang gagawin natin ngayon, kukunin natin yung values natin sa tape 1 and then kukunin natin yung sum. Okay, hindi lahat ha. Yung sum values lang ng tape 2. I-merge natin siya into tape 3. Okay, by merging, remember, kailangan sorted yung data. And then on tape 2, may matitira tayong 2 remaining elements. On tape 1, that will be empty. And then, ulitin natin yung process. Kukunin natin yung natitirang elements sa T2 and then yung sum elements ng T3 and then i-merge natin siya into the tape 1. Okay? So, tape 2 is empty and then tape 3 natira ngayon yung elements na hindi natin ginamit. So, we'll just continue the process until we come up with a single file na sorted. Okay? So, ang gamit lang ng polypace merging is to minimize the number of runs. So, kung makikita nyo kanina, we use 5 temporary file or runs. In polypace merging, we will just use 3 tapes or temporary file or what we call the run. So, that is what we call the external sorting. So, if you have any questions, just leave it on the comment section below.